Day 6, homework, real-life applications of equations and inequalities. Steps for solving word problems. Read the problem carefully, underline any key information, write a let statement, and write an equation. And then you solve. We were going to use this process for every word problem in this class. Nick opens a savings account for $500. He deposits $15. In how many weeks will he have saved $500? All right, so I'm going to highlight the given information. He starts with 50. So I'm going to call that his initial amount. That's his initial amount. It's also known as the constant because that amount does not change. Each week after, each is a keyword. Each week after he deposits $15. In how many weeks will he have saved $500? So this is an important sentence too. This is the rate of change. Each week, multiplication, 15 times the number of weeks. All right, so my let statement. The part that I do not know anything about is the weeks. In how many weeks will he have saved $500? So let W equal number of weeks. And so that way you tell the person that's reading your equation what the variable signifies. In this case, W is equal to weeks. We could have let X equal to weeks or N equal to weeks. The letter that you choose doesn't matter, but you just have to make sure that you tell the reader of your problem what the variable signifies. All right, so then we write an equation. So we start off with $50, and then each week you added 15 in. So if it was week 0, you just have the $50. If it's week 1, you have the $50 and you have 15 extra dollars. If it's week 2, I can kind of set this up over here so you can see visually what I'm talking about. All right, so at week 0, he has $50 because he already has that in there. At week 1, he has $50 plus an extra 15, so he's at 65. At week 2, he has $50 plus the $15 from week 1 plus the $15 from week 2, so he's at $80, and so on. So that's kind of the way to think about it. So what's happening here is you start off with $50 and then you are adding on $15 times the number of weeks. We've talked about how each means times, or per also means times. And then you want to know at which point, at how many weeks, will this equal $500? And so that's how I set up my equation. 50 is the constant, 15 is the rate of change, and W is the variable, so 15 times the number of weeks. In order to solve this, we circle, draw our line, subtract 50. You get 15W equals 450, and then you divide by 15. And so you figure out that the number of weeks is 30 weeks. You will have $500. There is definitely a way you can check this. You can say to yourself, all right, I know I start with $50 plus 15 times the 30 weeks. What does that equal? And if it equals the $500, then you know you've done it correctly. This amount is 450, so 450 plus 50 is 500, so it does work. Quick way to check. Plug in your answer for the variable. Katie wants to buy a bicycle that costs $129. This is 24 more than 3 times what she saved last month. How much did she save last month? The bike cost $129. That's important. This is 24 more than 3 times what she saved last month. How much did she save last month? So it looks like what I don't know is how much she saved last month. Let X equal amount saved last month. The let statements are required. They are not optional. They're required. All right, so let's go down through this. Bicycle, $129. This is in other words for equals. $129 is or equals 24 more than. More than, remember, is an adding word from 7th grade. 3 times. Times is a multiplying word. What she saved last month. I don't know what she saved last month, but I let X equal what she saved last month. Okay? And so I'm going to rewrite it so that you can see it as a regular equation. I'm just going to put the X right next to the 3 because that's more how you're used to seeing it. Circle, line, minus 24, minus 24. I get 105 is equal to 3x. I divided both sides by 3, and I got $35 is equal to x. It will, or she saved last month, $35. An answer to our question. You could plug that in. This is our check. I'll do it in blue again. 129 equals, I'll put a question mark there for you to see if it's true. 24 plus 3 times 1 times 35. This part is 105 plus 24. And it looks like, yes, 129 does equal 129. They balance, so the check does work out. We're in good shape. This incorporates the percentage stuff that we did last year. You have a coupon worth $18 off the purchase of a calculator. Not $18, $18 off. At the same time, the calculator is offered with a discount of 15%. But no further discounts may be applied. For what tag price on the calculator do you pay the same amount for each discount? That last question I think is important because it's asking you to do an interesting equation. All right, let's get our let statement. Let. What is the thing that I don't know the price of? I do not know the price of the calculator. So I let C equal the cost of the calculator. And you want to know for what price of that calculator will each discount be the same. So I'm going to put discount 1 equal to discount 2. That's how I'm going to set up this problem. Okay, discount 1. Take $18 off the price of the calculator. All right, well, I know the price of the calculator is C, and I'm going to take off, subtract $18. Okay, the other side. 15% discount. Okay, now I've talked to you about this until you're blue in the face. Discount means you take it off, you subtract. So we're going to do the same thing. We have a cost, and we're going to take off 15%. All right. So if I just put 0.15, which is 15% as a decimal, you are now taking 15 cents off of the cost. That's a really small discount. If I take 15% of the calculator, now I'm taking the calculator cost minus 15% of that cost. This is the correct way to put it. And then we've talked about how this is really 1C minus 15% of C, which is really the same as you paying 85% of the costs. Those are equivalent expressions. I like to call 85 cents of the cost the Tyler method because he always used to go to that right away instead of doing 1C minus 15% of C. I'm going to put a 1 in front of this C right here, and then I'm going to have you guys notice that there is a variable on both sides. There is a C on one side and a 0.85 C on the other side. We really like to get all the variables on one side because your whole goal is to get the variable alone. And I've always said to you that you can move either one. I don't care which one you move. I always choose to move the one that will give me a positive answer. So I'm going to subtract by 0.85C. Now something interesting is going to happen here. That cancels out. So this is going to become 0. So I have 0.15 or 15% of C minus 18 equals 0. And now this is a two-step equation. You circle, you add your 18, and then you divide by that 1500ths. Okay. 18 divided by 1500ths, and you get 120. $120 was the original cost of the calculator. Why is it that when I divide by a decimal, my answer gets bigger? The reason why that is because they're figuring out how many groups of 15 cents go into $18. Well, 15 cents goes into $1, 15, 30, 45, 60, 75, 90. It goes in there 6 times and then it has a little bit left over. So that's just $1. You're doing that 18 times. So it goes in at least 6 times for each dollar, and then there's a remainder. So that's why it's such a huge number, because 15 cents goes into $1, 6 and a little bit times. All right, number 4. The length of each side of a regular pentagon, all sides are the same length, decreased by 2 centimeters. The new perimeter of the pentagon is 55 centimeters. What was the perimeter of the original pentagon before its sides decreased in length? All right, important pieces of information. It's a regular pentagon. All sides are the same length. That's important. The sides are all decreased by 2, which is another nice way of saying minus 2. The new perimeter is 55 centimeters. What was the perimeter of the original pentagon before its sides decreased in length? You might be thinking right now that your let statement should be let x equal perimeter of original pentagon, or you could be thinking let x equal the original side length. I don't think you can do let x equal the original pentagon perimeter, because your first sentence is all about the sides. You can totally use the side lengths to find the perimeter. So I'm going to let x equal original side length. And the nice thing about it being a regular pentagon is that all those sides are the same length, all 5 of them. because it's a pentagon. Okay, so you could do this one of two ways. You could say x minus 2 plus x minus 2 plus x minus 2 plus x minus 2 plus x minus 2 is equal to 55. All 5 side lengths of the new length add up to 55. Or you could notice that they're all the same. So there's really 5 of these x minus 2 side lengths. So either way is fine, whichever way you want to write it. You're going to notice that this is a distributing problem now because there's a number outside the parentheses. So you basically have 5 groups of x minus 2, which means you have 5 groups of x, and you have 5 groups of negative 2, which is negative 10. And you get this two-step equation that you know how to solve really well. You circle, add 10, add 10. You get 5x equals 65. Divide by 5, divide by 5, and you get x equals 13. That is the original side length, because what you did is you figured out that when you subtract that by 2, and you have 5 of those, they give you the new perimeter of 55. So if you had the original perimeter, then that would just be x. The perimeter of the new pentagon is going to be, I actually should erase the box around this because this is just one side. We are now going to find the perimeter. Perimeter is 5 times 13. So the perimeter of the original pentagon was 65 centimeters. Each of those sides was 13. 13 plus 13 plus 13 plus 13 plus 13, or 5 times 13. So that is the perimeter of the original pentagon. Mr. Jones had 3 sheets of stickers. He gave 20 stickers from each sheet to his students. He had 12 stickers left. How many stickers did Mr. Jones have initially? Okay. 3 sheets is important. He gave 20 stickers from each sheet, and he had 12 left. How many stickers did he have initially? Let's have it be n. Let n equal the number of stickers. And I'm going to say on each sheet, because the information we have is 20 stickers from each sheet. So I'll let n equal the number of stickers on each sheet originally or initially. Alright, so he has 3 sheets of stickers. He got rid of 20 on each of them. So I'll get rid of this guy for a second. Let's just take that got rid of 20. So I have a sheet, and I'm losing 20 off of it. That's happening 3 times because he has 3 sheets of stickers. So this has to go in parentheses because that whole thing, that whole n minus 20 is happening 3 times, not just the n, not just the number of stickers on each sheet. You want to group it around the whole thing. And then when he takes 20 off of each sheet 3 times, he will have a total of 12 left. So that is our problem. You could, same way as above, you could do n minus 20 plus n minus 20 plus n minus 20. You could do that 3 times. It's the same thing. 3 times n, and then you're really taking away a total of 60. 3 times negative 20. This is a 2-step equation. You add 60 to both sides. You get 3n equals 72. And you divide both sides by 3. And you get n equals 24. Okay, so he started with 24 stickers on each sheet. And he got rid of 20 on each sheet. So then at the end of the day, he started out with really 24 on each of those 3 sheets, right? Or 24 times 3. So he started out with 72 stickers. Okay. Number 6 is going to be a challenge problem because I have run out of time. If you come in with that problem done tomorrow and it is correct, I will come up with some kind of prize to give you.